Yo, what up? Is this thing on? Can you guys hear me? Hello, hello. Cool. All right. Looks like it is working. At least I can hear myself. Um, so I don't have much time. My system's gonna crash any minute now. I've been dealing with some weird issues with my system, so stream ends when the computer crashes. So I'm gonna do some work and see what we can get done. And if my computer crashes, it crashes. If we make it to 2.5 hours, then we do. So I let me change something real quick. I'll put that here. Rashes. Coding into my system rashes. That sounds gross. Okay. Um all right. So last thing I was doing, I believe was working on the brightness, setting the panel brightness. I think I had the function for that all the way down here. Yeah, there we go. So the GG set main brightness function was what I was working on last, trying to get that to work. I got it to work to set the brightness at a 0 value and turn the display off effectively, but that's not entirely useful. So when I tried to turn it back on, it wouldn't work. So I should probably figure that out. And then off stream, I worked on a little bit of documentation because I want to sort of have some documentation in place. It's pretty basic at the moment. I need to go in and work on the formatting of this and then also add some more detail because there's a lot of things that I need to cover to make this a little bit more usable for randos. But in general, we can preview the markdown. Check that out, see what that looks like. So for now, we've just got kind of like a basic README file talking about how this is an at-home Linux driver for our DisplayPad hardware, and goes through our features. We've got our hardware control, our background service where you can control OBS, on-the-fly panel config switching, all that fun stuff. And then I want to have a section over here for installing, setting up the library and getting it configured on your system. And then I also want to make a systemd unit file to ship with the code so that we can make that easy for the end user to set up. And then I have some sections for configuring, how to configure the OBS WebSocket, what all the panel JSON settings mean, and what the different action types are. I want to find a different way to break this down and make it more readable, just because this looks kind of ugly. It's also not finished, but it also looks kind of ugly, so I want to clean that up and make it look a little bit better. So that's cool. So I've got that going. I also wanted to work on packaging, so I've got this open. And I was messing with that. And what else do we get? I think that's about it. I think that's about all I did last time you guys saw me. So I also have a I set up the stream a little bit different OBS. So we've got a little bit of blank space down at like the bottom and on the right hand side of the display, the screen. So I can have my to-do list up there at the top right, and it can be, a bit more extensive. I can have more things and it not clog up the screen or anything like that. And I don't have to have it underneath my little camera bit. And then I also set up the camera to be a bit smaller down at the bottom right, so that we can hopefully have more of the actual content visible and easier to see. And I hope this is all still readable for everybody. And then down at the bottom of the stream, I've got a section for the chat box. So that way when the chat actually says something on the rare occasions that they do, I can see it in my OBS view instead of having to swap to my Streamlabs tab. I don't know. There's like 800 different ways you can set up a stream. But anyway, I wanted to work on the function for setting the brightness, which is down here. This is our GG set main brightness. I wanted to dig into this and see if we can get the right value going out to the device, and then actually update the display. So what I want to do is I want to print out just the message for this. I don't want to actually update the brightness or display pad work. I want to make sure that this isn't, this is only going to call it once, and then it's going to do everything else that it normally does. And then it should spit out the value of the set main brightness. Real quick, let me fire up my Windows virtual machine. I don't know why I don't have that one running. Let's fire that one up, and we will check out the stuff in ghidra and make sure that we're doing everything that it's expecting us to do. I believe this value, the max brightness value, is supposed to be a max of 64. So I don't know how many steps they have. I believe it's like 4 steps between like lowest brightness and brightest brightness. So I don't know if there are more. I don't know if there are more steps, if we can be more granular or not. But that might be something that we can try to see if we can get more granular brightness values out of it, because in their software they have a little slider that allows you to change the brightness, and it only has 4 steps to it. So maybe we can get some improvements. I guess the Windows VM is still turning on. Okay. We'll let it do its thing. It'll take a minute. Yeah, it's still going. Okay. Oh, it's doing Windows updates. Classic. Okay. Whatever. We'll let it do its thing. So for the max brightness, so what are we doing? We're taking our value and our header and we're packing them into a struct. Let's just see what that's spitting out while we wait for our VM to turn on. We'll source our virtual environment, and then we will do Python 3 displayPad worker. And that should turn on our device. Nope. Unsupported operand types. Oh, I've got to put the OBS WebSocket password in here. That was another thing that I need to do. Let me add that to my to-do list. OBS WebSocket. It checks for all right, add checks for the environment variable. Cool. So, and what I mean by that is I'd like to have some checks in place so that if there is no environment variable for OBS WebSockets, it'll fail gracefully. And then if there isn't an OBS WebSocket like command, I think I already set that up. I think I already set that up under the panel where it goes and checks to see if there are config items. Load panel config. I believe I added that in here. I'm getting distracted. Oh, that's probably back here under the display pad worker. Yeah, So this is check to see if we have, this gets our OBS handle. If there are OBS commands in any panel config. So this is also where we can check to see if our, or I guess we do that over here, where we initialize based off of our environment variable. Let's see, we could probably wrap this in a try and accept. I think that's how you do that. And then we want to return false. Get OBS handle. So where is that getting me? That's getting called get OBS handle. If self handle, actually, if not self handle, then we return false. Or we just, let's log an error. Do, 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 do. Am I even logging anything in here? Alright, could not get handled to OBS WebSocket, and then we return false. So then if we go back into our panel config, where we go to get the OBS WebSocket, I think that's where we do that. No, we would do that over here because we broke it out so that it would be, let's see, if not OBS handler, return, actually we'll just do, let's see what that does. Should just error out. No, because we're not handling that exception properly. Type error, unsupported operand. Oh, I think I need to put this elsewhere. Which I believe, let's set this to false. That way, if it doesn't get anything from that value, it'll return false. If not password, return. All right. Name log is not defined. Oh. All right. And then that should alleviate that error. Mm, that's interesting. Yeah, I don't really mess with Python classes, making my own Python classes that often, so let's see. Um, we'll return on that should still work. Because then it'll still return a not, air quotes, not value. OBS integration connect can't handle the OBS WebSocket. Okay, cool. Now that fails gracefully. Does it? It still runs that though. Oh, we need to break, right? Oh, wait. Oops. Yeah, break only works in a loop. It says cannot. Oh, see, that's the error. OBS integration cannot get handled OBS WebSocket. So then that returns none, right? Print OBS handler, right? Because that should be none. No, it still gives an OBS handler object. Right, we'll just do that. If it doesn't get the password, it'll set none for that handle value, and then over here in the worker we can check to see what that handle value is. Dot handle. And then we'll log that. There we go. I think that's better. We'll see. None type object has no attribute call. Bruh. Self handle. So what the fuck does that do? What's the difference here? What am I messing up? Connect can't handle the OBS WebSocket main. Okay. That is... Ah, interesting. Okay, so that kind of short circuits the init. That makes sense. All right. So if we don't get that, then that actually cuts it short. So we can do our OBS WebSocket. Is it export? Export that. Add our OBS WebSocket key, and then we rerun this. And that should get us our set main brightness value. And so that sets it to FF for 255. But what we want is 64. Where are we at? Okay, so what I need to do is get this value to be Um, actually, let's check our VM. See if our VM is going. How are you doing, Windows? Okay. Alright, cool. Let's get, I guess we don't need ghidra running. Where is our wireshark? So we'll get wireshark running and we'll open our saved pcap. And then take a look at those messages that we had. Might take a second. I don't really provision these VMs to be super fast. So anyway, let's set our max brightness to 64 just for shits and giggles. But 64 in hex is not the same as... Cyber Chef. Let's go. I don't know why I have this bookmarked. Cyber Chef is the goat. Bookmarks toolbar. Save. Alright. So 64, if we convert that to hex, gives us 3634. And I believe 64 is the maximum amount that the device is expecting over the USB protocol. Someone tried deleting their System32 on their computer on YouTube. That's funny. That didn't work out for them. Let's get okay, Wireshark's open. At least thought it was. It's still thinking about it. Wow, Wireshark is really taking its sweet time. Is this exciting? Do you guys like watching this? How are y'all doing today? I think what I had it before was D. I think D was it D? Lowercase d? There it was, lowercase d. Um, oh, that's alright. You don't have to be a technical person. You can still learn some stuff. So do you know what a stream deck is? Like the little like control pad with like a bunch of buttons on it and screens? And like a screen behind the buttons? I've got like a knockoff version of one of those. And I'm reverse engineering it so I can make it work in Linux, because the manufacturer did not make it work in Linux. It only works in Windows for them. Let's just try. Let's try, we'll send it the value B. It'll be 63. That should set the brightness to something. Gotta uncomment these. And then we will rerun it. See what it does. Oh, nice. Oh, it's because I'm doing comparisons right here. I don't need to do comparisons. I just need to check the value at the device. We'll figure it out when we see if we can actually do multiple whatcha-who's-its. So this sends that, I don't know if that actually did anything to the device. Here, let me get this off the stand. It looks like this thing. It's like a little thingamabobber with buttons on it. You can push the buttons and they do things. Let's see. I got so much crap on my desk. So why is this not runs get main brightness and then oh, that's right, I short-circuited the running value because I didn't want it to go into the main loop when I'm just trying to set the brightness while I'm testing that. But just to show you guys what's going on. Hey, what's up, Patrick? Let's see if it'll actually work. Let's see if the demo gods will bless me. So we run our program, and it should pop up with some stuff on the screen. Oh, there we go. Demo gods. All right, one sec. I just changed this to true. Stupid. So stupid. All right. Ow. Demo gods, bless me. Hey, there we go. So that's what we've got so far. And I can, let's see, push buttons, make it go to a different panel, make it go back to a different panel, and then I can also do key bindings, and I can launch applications. So that's cool. Yep. So that's what we've got so far. Right now I'm working on setting the brightness values for it. So let's see if Windows is playing nice now. No. It's okay, there we go. Alright, let's get our, I don't know if I had a save capture for that. Got key presses. Yeah, the simplified steps is I used Wireshark, this tool right here, to capture the traffic that goes between the software that is designed for this device. Let's see if I can find where is it at? Oh, leftover capture data. Apply as column. Oh, there it is. So I use Wireshark. This tool will let you basically sniff traffic over the wire. It's meant to be used for like Ethernet traffic, but you can also install a tool called libUSB pcap, and that'll let you capture USB traffic. So I hooked up the device and set it up with like its default software that the manufacturer provides with it that works in Windows, and then I captured traffic between the software and the device when I would change things. So, and I can show you that really quick because I actually have to go in and get a capture of the setting the brightness values. So I'm going to replug this in and then pass this device to the other virtual machine that I have. All right, so now this should be attached to Windows. And if I run their software, I can show you. Oh shoot, I forgot to set up the capture first. It's gonna take its sweet time. Let's go ahead and, so this is our USB capture device. And I'm going to configure this. I'm going to capture from newly connected devices, and then we're going to start that. And I'm going to come back over to the VM and undo the device. And then come back and re-add it. So then you should see, yeah, wireshark should start to do some stuff. Let's get rid of that. Is it the data field? HID data? Yeah. I don't know why Windows is like this. Sometimes it'll pick it up as leftover capture data. Sometimes it picks it up as HID data, whatever. So anyway, let's go ahead and I want to filter, prepare as a filter, not selected. I want everything less than or equal to that. I don't want to look at that. I want to look at new stuff. So I'm going to go ahead and go into the software that comes with the device. This ships with the device. And I'm going to go into customize. And you can see it's already rambling, going in doing some stuff. And I'm going to go to settings. And what I'm interested in are these brightness values. So let me clear this one more time. Our last frame was 3746. 37. Oops. Helps if I have numlock on. Actually, let's just do this. Do, 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 do. All right. So then when we come in here and we change our brightness value, you'll see it actually sends some packets to the device. And that's what we're interested in. So yeah, so it looks like 4B. Not sure what that is supposed to be. But it's packing this data in here. So the actual value that it sends to the device, this what's in this HID data string, is this is getting sent to the device, and then there's a portion of this little 64. That 1 byte is being parsed and turned into a brightness value. So I need to figure out what that actual value means, and then translate that into my own code so that I can tell it to change its brightness. So that's where I'm at. I've done quite a bit of reversing other functions of this device so far. I just need to, I haven't really dug into this one super deep to get it working, just kind of the basics of it. So I want to get that actually functioning so that if you want to set your brightness to a different value, you can. You can just change it in the config that I'm setting up. But let's go back into Linux. I want to see what that value is. I made a bookmark and didn't even use it. Okay, so it is 4B from hex. Interesting. Let's see. 2 octal? 64. I don't know. No, wait, from octal. I'm not sure what the actual encoding that they're using for the brightness value is. You would think that it would just be like 1 through 255, but the max value that they have in the actual packet is 64, and then like this half step, let's say, put it back to half. This half step is like 32? Where did 4B come from? What is that? Is that one? Yeah, 4B. Okay. And I'm probably just getting confused on the encodings. I don't know. Hmm. So I wonder if... I wonder if Wireshark is converting it to hex, and that's throwing me off. Um, oh, that's interesting. Let's see. Let's try to send, I did send 63. Let's try sending 1. What would be 1 in ASCII or octal or whatever? Let's see. Oh, nice. Hex. Let's just see if we can send. Oops. Then let's change our max brightness to hex. Oh shoot, what is it? And this is probably not gonna work. We're just gonna double pack hex in there. Oh, I want to short circuit this again. Do, 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 do. Okay. And then I'm also gonna have to pass this back into Linux. So before we do that, I want to stop that. Save as. All right, cool. And then detach this from that VM and attach to this one. Oh, that's funny. Do, do, do. All right, cool. This is interesting. It's still on and initialized with the same settings from the stock hardware. Bytes like object is required, not integer. Oh, do I need to send it 2 bytes first? Where are we? Let's see. Let's set the value to 0. I don't think that's actually going to do what we need it to do. Let's see if this actually turns the screen off. No. Let's see. Oh, string object has no... Oh, yeah, dead boy. Still looks like it's sending the same thing. Interesting. Am I not printing out the right value? Oh, that's why I'm not even hacking the value in there. That's dumb. Okay, so max brightness. Da, 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 da. It helps if you do the thing right and you don't just screw it up. All right, now let's see it throw some errors. Or it'll work. Yeah, there we go. Okay. And then let's see. Actually, I think we can just convert this to int. There we go. Yeah, if you guys haven't noticed already, I have no idea what I'm doing. Let me get ghidra open. I don't know if that'll help me figure out what the hell it's doing with these values or not, but oh, did I have Windows open? Also, I'm a girl, by the way. So, if that helps. Come on, ghidra. What are you doing? Okay. I guess ghidra doesn't want to run for me. How many cores do I have on this damn thing? You've got 4 cores. Okay. Oh yeah, cool. Double launch. That's what I get for being impatient. Alright, cool. So, let's open that. Also, who does that? Who the fuck goes into someone's channel and says, hey, when are you gonna cut your hair? What kind of shit is that? That's stupid. Alright, so our function, let's see, exports. Set main brightness. Alright, let's go into here. Alright, let's try to understand what the hell they're doing with this thing. So the by brightness is a byte value. And where are they going with that? So if by brightness is not equal to 0, then local force equals our brightness. Let's see, local by brightness. So this is our header that's in our message, the 12 and the 3. And that is this part right here. You see 12 and then 3. So that's the header. And then we have this whole byte value that is our brightness value. So we need to figure out what the hell that means. Hmm. Then what does it do with this? It packs all of that into this memory region, I guess? I don't know. I'm an idiot when it comes to assembly. let's try to look over here at the actual assembly instead of the decompiled view. So our by brightness, ugh. So move instruction, moving that into our value, I guess? I don't really know. So it's not really manipulating it, it's just a byte value. It's not doing anything to it. It's not changing it with anything or adding it to anything. It's just a straight up byte value. Huh. Okay. Which I guess that makes sense because 32 is just the ASCII character 2. Yeah, assembly is very confusing. It doesn't help that I'm not super versed in like low level languages. Um, so this is probably like as low level as I get. If I was more experienced with like coding in C, I'd probably understand a little bit more about um, how data types are represented in memory. Um, but normally what I'll do is I'll just stare at this long enough and then it makes sense. So we're adding this value to our stack pointer. 0xc. Oh, hey, look at that, /f. So I guess it's the end of a string, or end of a, /f is a terminator. So I guess that's for this memset right here. I saw that at symbol just a second ago. Is that, okay, so yeah, maybe that's for the, maybe that's for the actual URB message header. Because with the actual packet data length, is that what this is? That's the packet data length? Okay, interesting. So let's go ahead and label that. Memset packet data length, and then there's some other value, which is 0, and then this is our actual message. Yeah, exactly. And that's something that makes this kind of interesting is this device that I'm working on um, uses a totally different like instruction set. It's an ARM-based processor. So it's I guess doesn't the data that you send to it over USB gets translated differently than what it would if you were talking to, I guess, x86. And so that's probably why they're doing things like packing byte values into this HID data, and then on the device, it's actually interpreting that as something that it has pre-coded. So it's not like so I don't know. I guess I don't know if I knew a little bit more about the architecture, I could probably answer the question. But I think instead of just like saying, "Hey, I want to set the brightness to 100% or 100," that 100 is gonna once you send it over the wire, that value is gonna be different on the device when it listens to it and actually interprets it from the wire. So you have to pack the data in a way that gets unpacked on the device side in a known manner. So they've kind of like made this little protocol that they talk to the device with. So this at symbol, this 40 byte value, I think that is this right here. And that's the message length according to Wireshark. The packet data length right here. So it's specifying, hey, I'm going to send 64 bytes of data. And then this is 64 bytes of data right here. And then within that 64 bytes, I'm not sure what that's for. Maybe that's some other part of the protocol. Yeah, I don't know. But then our message is comprised of this 0x12 and then 0x3. I don't know why it just says it's 3 in decimal, but that comes through as a byte value. I don't know. Maybe it is 3 the number. Who knows? And then it packs our brightness value onto the end of that as well. And this is supposed to be a byte value. Let's see. Actually, I don't need that. Let's go back into Linux. So we know that it's not actually doing anything to the byte value. So we go back into Linux. Let's see. Python int 2 bytes. Let's get the AI summary. We'll see if it's right. Yeah, so we need to specify our byte order as little endian because that's what the device is expecting. Let's go ahead and open up another terminal. Let's do, I don't know, 255.2 bytes. Actually, we're just saving it in a variable. A equals 255, and then a print a dot 2 bytes. And what was it? Byte order equals little. I think that should pack it properly. We may not even have to do that if we're doing it from the struct method. Interesting. I just don't know what the relationship between these values that they're sending through the software. Like 4B, I don't know, that doesn't necessarily, like the letter K doesn't necessarily translate to, I don't know, a percentage value of the brightness or something. Hmm. Yeah, it looks like it just takes the byte value and then passes it to the device. This is our send message function. Maybe it doesn't actually have multiple brightness settings and you can only set it to whatever the hell they want you to. There's only like 4 steps or something like that. Interesting. So I think in my Python, let's go ahead and let's see, can we get this as hex? I hate doing type conversions. Built-in hex function. Alright, we'll see about that. Bytes object cannot be interpreted as an integer. Let's see. Oh, thanks for subscribing. So 4b from hex gives us the letter K, in ASCII, but let's see, to oct. Let's go to octal, which is 64 and 142. Because there may be some particular, what I feel like is there's some sort of encoding. They're like, they've got like a sliding scale of like, I don't know, 1 to, or 0 to maximum brightness. And then what they're doing is they're, on the device, they're interpreting a byte value somewhere along that scale. So I'm trying to figure out what the difference between like the, I guess, maximum and lowest brightness value would be. So 4b is in between, right? No, 32 is in between, 64 is the most. And then this is kind of like a 3/4 of the way their value. And it's probably confusing me even more because these are not actual integers. It's just byte values that are converted into hex. And that's what so Wireshark is showing me. So yeah, the value of 4b is like the 75% setting is like 3/4 of the way there. Let's see. Is it really? Is it let's see, 2 hex. Hmm. This is the part where I suck at hex. What do you mean, Patrick? Hexadecimal of 32 is 50? That's if it's out of 64, but wait. Okay, hold on. Let's do some learning. Because like 255 is FF. So if you're going to like F, if it's like a 1 byte hex value or something, I don't know. Yeah, it seems like 64 is the upper bounds of like the brightness value. 32 would make sense if it was like digits, like integers. But then you have 4b. That's the one that's throwing me off, 4b. Oh, you know what it is? I think it's CyberChef. I think CyberChef is fucking with me. Hold on. Because CyberChef doesn't really do integers. Ooh, punch tape. There we go, that's what I need. I need punch cards. That'll help me. I think you're on the right track though. I mean that's basically what it seems like it's doing. Is it's taking like a 1 byte hex value. So like only goes up to F, not FF. Mm, oh, I'm confused. Oh, my brain. uh, let's go stare at the let's go stare at the assembly longer. That usually works, right? All right. Yeah, I think what CyberChef is doing that's throwing me off is it's interpreting like 4B as a string, and it's throwing off my it's throwing off the conversion from uh throwing off the conversion to hex. So let's just try it. Let's mess around with max brightness is value. Oh wait, 64. Then we'll just convert it to a byte value and then send that. So and then I think we can just do that. Let's check Python struct hack. Thanks, GPT. I normally do streams on Tuesdays and Thursdays. But we're going into my machine crashes because I've been troubleshooting some stupid problem with my system. So we'll see if we get to 2.5 hours or not. Let's see, where's our formatting? This. Let's do a byte value. Single byte. I don't know if it's gonna like that though. We might have to convert it. Do C. See what that gives us, and then okay, so that's short circuited. Okay, I just want to see what this prints out. Character format requires a bytes object of length 1. Let's just throw a 2 bytes on there, see what that does. No science. Okay. So 40. So put 40 at the end, which is not right. It should be 64. Because, wait a minute. So 64 is the hex value of D, which is a byte value.